Hi everyone. In today's class, we'll be treating heat, temperature, and thermal expansion. So, without further ado, let's go on and start the class. Now, according to the heat definition, it is one of the essential forms of energy for the survival of life on Earth. Now, heat itself is an energy, and it has an electromagnetic characteristic, which is the infrared. When I was explaining heat transfer, I made mention of this. So just focus on the fact that heat is a form of energy, and some of the indication of heat in the body is the temperature. If the body has a lot of heat, the temperature will rise, and the heat energy itself, is as a function of the kinetic energy of the molecules of that particular body. So if the motion of the molecules of that particular body increases, the temperature will increase, and then if the temperature increases, that obviously the heat will as well increase as well. And heat energy is constantly in a flow. The heat is not always held in a region; it's always moving, because there's always a difference in temperature between two bodies. It tends to flow from a body with higher temperature to a body with lower temperature. And it also can be leveraged to actually provide other forms of energy. So you can convert your heat energy to other forms of energy, like kinetic, like potential, like chemical, quite a lot of them actually, to electric also. And since I said that heat is like the measure of is a function of temperature, it directly influences the temperature. So that means that temperature is more like the measure of the hotness or coldness of the body, because whether the body is hot or is cold, it depends on the amount of heat that the body is generating, or the body is generating. So temperature is the measure of the hotness and coldness of the body. And then you have different units for measuring temperature. You have a lot of them. Aside from this one there, you have a lot of them. You have Celsius, you have Fahrenheit, you have Kelvin, you have Rankine. But then the one that is accepted in physics is Kelvin. Like the normal standard unit for temperature is Kelvin. I already made mention of heat transfer in a particular video. Now let's talk about. They didn't say anything about it. Let me just talk about this. The different temperature difference, the different temperature scales. Now Celsius, the upper limit of Celsius is 100 degrees Celsius. Now you can go higher than that, but then with respect to the boiling point of water and the melting point of water, the highest point is 100 degrees Celsius, the lowest point is 0 degrees Celsius. You can go lower than that as well. Now Fahrenheit lower limit, which is equivalent to 0 degrees Celsius, is 32 Fahrenheit, while the upper limit is 272 Fahrenheit. While for Kelvin, the lower limit of Kelvin is 273, while the upper limit is 373 when you add the 100 for water. Now the way you calculate Fahrenheit scale is quite different. It's a little bit different from all others. For Celsius, now you just have to just add it together. Add 100 degrees Celsius to, like, if you are trying to convert from Celsius to Kelvin, you just add 100 or whatever value you have for the temperature to that of to 273, and you get your answer. But then for Fahrenheit, it's a little bit different. Now for Fahrenheit, it will be 9/5 times the temperature in Celsius, and then after everything, then you are going to add plus 32 to it, so you get your temperature in Fahrenheit. While if you are trying to convert from Fahrenheit to Celsius, it will be the opposite. So if I was subtract 32 from it, 32 Fahrenheit from the value that you have in Fahrenheit, and then you're not going to multiply that value that you have now by 5/9, and then you get your stuff in Fahrenheit on the Fahrenheit scale. So that's basically how you do the whole conversion. So we're still going to treat more of this in class. I will actually spend a lot of time to actually do the practical, because this part might be a little bit. This last topic might be a little bit tricky, and the previous one too, which is surface tension, viscosity. So now since we're done with heat and temperature, now let's go to thermal expansion. Now thermal expansion is very very simple, but then the only issue you might have there is what's called is making small mistakes, or it has to do with a lot of small values. So you might tend to probably miss 1 0 or something, and then that will affect your entire answer. So what's thermal expansion? Thermal expansion is when you supply heat to a body, the body tends to expand, because that energy you are transferring to the body set the particles of that body into motion, such that the body tends to, how do I put it, so that the body tends to separate from one another. They have more energy now to separate, to depart from one another, and when they depart from one another, they are expanding. So that's thermal expansion. Now you have more 3 different forms of thermal expansion. You have the linear expansion, you have the area expansion, and you have the volume expansion. Now linear expansion is just change in length due to the increase in temperature. So that means you have, and to calculate, now you have coefficients. You have the coefficient as well. So you have coefficient of linear expansion, you have coefficient of area expansion, you have coefficient of volume expansion, and which is referred to, coefficient of linear expansion is referred to as linear expansivity, while coefficient of area expansion is area expansivity, while the coefficient of volume expansion is referred to as volume expansivity. So this is the formula for calculating linear expansion. So you might not necessarily ask to calculate linear expansion, you might be asked to calculate even the temperature difference, or to calculate the coefficient of linear expansion. So you just make linear expansion formula, and then you have your answer. And you know that delta L is equal to the new length after you've supplied the heat minus the original length, because that delta L is the length difference when you supply the heat. Now this same stuff applies to volume expansion, just that instead of using length, you are going to use what? Volume. The same thing applies for area. Instead of using volume or length, you are going to use what? Your area. You are going to use your area. Now that delta T is also a temperature difference. When you supply the heat, the temperature will have increased from so to something. So you look for that value, and be careful as well too of the unit. It has to be in Kelvin. You have to convert it to Kelvin. If you don't convert it to Kelvin, most of your answer will be wrong. Try to make sure that you convert to Kelvin. So I think that's that. So you can pause this video and attempt this question. Now here's the solution. So see you guys in the next class, where I will dissect most of the questions very well.